So covalent bonds are formed with which type of elements? We had metals and nonmetals for ionic. Now what are we going to have? Just nonmetals, yes. Nonmetals with other nonmetals. It could be with another nonmetal of the same exact atom, or it could be with another atom. We will look at these different types now. So there's three different types of bonds in covalent. We have single, we have single, we have double bonds, and we have triple bonds. I will show you examples of them. At this point, you might say, how do I know that it's single, double, or triple? And at this point, you don't. I'm just going to show you what they look like from examples that I know of. Tomorrow, I will show you how to make that determination. That if I say H2O, you should be able to come up with single, double, or triple bonds for H2O. Or CO2, you'll be able to come up with single, double, or triple bonds. And we're sticking with small molecules, but you'll be able to figure out what the bonding is. It's not crazy tough. It's kind of amazingly fun, like most of chemistry. So here we have hydrogen with another hydrogen. That's going to be my first example here. Hydrogen with another hydrogen. How many valence electrons does hydrogen have? Uno cabuno. So here's one for that hydrogen. Well, this other hydrogen also has one. So they can share each other's hydrogen, or each other's electron. Now hydrogen's strange. It is actually an exception to the octet rule because it doesn't need 8 to become stable. It needs 2. Because once it gets 2, it looks like helium. And helium is a noble gas. So the majority of things, when atoms, when they get done sharing for a covalent bond, they share. When they get done sharing, most of them will have 8 around them, 8 dots that they are sharing. Hydrogen is an exception to that. There's exceptions to most things. And there's only 2. And I'm just showing you this just to show you where those are coming from. All right? If we think about those electrons, each of them are sharing those 2 electrons. Each hydrogen is sharing one of the others, so they each have 2. So that's how they both satisfy the octet rule. And I know in this case it's the duet rule, but the only 2 electron rule for hydrogen. But they both are stable by sharing the other's electrons. All right? Let's look at 2 more for the single bond, just because I'm going to run out of space here. But let's do it. I'll move it over a little bit. So let's do hydrogen again with 1 electron next to chlorine.
Why are we doing it inside the lab?
Well, I think we're going to run out of room because I want to put another one here too. All the other ones I'll just do 1, but this one it's fun. Well, they all are. But how many valence electrons does chlorine have? It does have a lot. 7 of them because it's in group 17, yeah? So I'm going to put 1, 2, 3, 4, 5, 6, 7. Now, hydrogen will share 1, and chlorine will share 1, and both of them will be happy as larks, because we think larks are happy for whatever reason. Hydrogen has 2 now. Chlorine has how many if we circle all these? 8. Now I'm just circling them for you, and you might say, do we have to do that every time? No. I'm circling it for you in the examples just to show you how they become stable. And since you all have that, and I have the ability to erase, I'm going to do that. I'm going to erase so I don't run out of room. And I know you might say, well, I can't do that. I'm going to run out of room. That's okay. All right. I'm going to take another halogen. I can pick any one. It doesn't matter. I'll get the same result. I'll pick bromine next to another bromine. How many valence electrons do each have? Bromines? 7. Every halogen has 7. There's 7 for that bromine. 1, 2, 3, 4, 5, 6, 7 for that bromine. And if they share these 2 electrons in a single covalent bond, because a single bond is only sharing 2 electrons, they both become stable because they both have fulfilled the octet rule, and they both have 8 electrons because they are sharing one of their friends' electrons. So those are just me showing examples of how they form. Now I want to talk about what a Lewis structure is versus a structural formula. There are 2 different types of Lewis structures, just to keep it fun. This is one of those things that's on the test, 6 and 7 tests, and people take the test and say, so structural formula, we didn't do many of those. We did a lot of Lewis structures. What's the difference? And I'll say, remember that day when I said that that will be on a test and you'll ask that question? No. Well, I did, and now you're taking the test, and now you don't remember. So maybe make a little star or something about structural formula. All these things, you'll need to be able to do them for the test. But we'll be practicing Lewis structures a lot in the next week, and you might forget about the whole structural formula aspect. All right? So let's show the Lewis structures we just did, but with dots. So we did hydrogen. You might say this looks like just like what I did. I'm just not going to make any circles now. Yep. With electrons or with dots, same thing. Dots as electrons.
So
pretty much what we just made, but I'm not going to circle anything now. Yeah, each dot represents an electron, so with dots or with electrons pretty much means the same thing. And what the dots, why I'm saying with dots, is dots are shown as electrons being shared. 2 electrons being shared per single bond. How are they different with dashes? Well, each bond gets a dash, and each dash represents 2 electrons. So that is another way of doing a Lewis structure. But the non-bonding pairs of electrons need to still be shown. The non-bonding electrons still are shown with all Lewis structures. So it's just a small difference. Lewis structure with dots shown as the bond, Lewis structure with dashes shown as the bond, or a dash because it's a single bond. A structural formula would be most people's favorite, but we kind of have to start with Lewis structure to get to it. And that is just showing the bonding, and that is it. That is how it is different. Simply showing the bonding. No unbonded electrons. So I showed you 3 examples of a single bond. But a single bond, in review, is 2 electrons being shared, and when 2 electrons are shared, it is a single bond. Why do covalent bonds form? Because all elements included, all atoms included in a covalent bond will be stable because they will satisfy their octet rule to do so. That is the goal of any type of bonding. Remember with ionic, the metals lost them, become like noble gases. The nonmetals gained electrons, become like noble gases. Now we're just sharing to become like noble gases. Okay? The double bond example I want to show you is oxygen. Whoa. Oxygen has 6, I just heard. Yes, it does have 6. I'm going to show it a certain way because I can make a clown or a pretzel by doing so, and it's just entertaining to me. So there are 6 valence electrons for each oxygen. Even though one looks like it just disappeared, we'll put that one back. If we only shared these 2, like we did on the last time, if we only shared these 2, that would only give each one of them 7. So they're also going to have to share these 2. And that is why we end up with a double bond. Because they do not get their 8 by only sharing 1 pair. They need to share 2 pairs. And now if I show where those 8 electrons come from, it looks like a pretzel or a clown. There's my pretzel. I'm just circling the 8 electrons that count for each one. And it's just fun. If you're scared of clowns, think of it as a pretzel. All right? But again, I'm just trying to show you why it has to be a double bond. How would you actually show the Lewis structure? you would show 4 electrons between the 2 oxygens because they're sharing 4 to make a double bond. How many pairs of electrons do each oxygen have around it after that? How many pairs? 2 more pairs, right? And they're typically shown at angles, and you'll understand this a little bit more why later. Those electrons like to repel each other, so we put them at angles like this. And I'm just going to do that for you now since that's typically how they're done. So if I look at this oxygen, there's 8 electrons around it, including these 4. And I look at this oxygen, there's 8 electrons around it, including these 4. So both oxygens are stable and happy and like a noble gas.
So you can have there be 4 in the middle?
Yep. And both of them can count those 4 as part of their 8. So that's what happens when you share. Just like the ice cream scoops. You share those ice cream scoops, the polar bears, 2 polar bears sharing 4 ice cream scoops, they both get to have some of those ice cream scoops. It's just like anything. If you're sharing something with your brother or sister, it's wonderful. You say, hey, I've got, and if you, like my boys, they happen to wear the same size, they say, hey, I've got 2 shirts, you have 2 shirts, why don't we share? We can both use these 4 shirts. It's wonderful. It's the same thing with oxygen. And they say, hey, I've got these 2 electrons. You've got those 2 electrons. Let's both use these 4 electrons. It's perfect. It's a match made in oxygen. And this is the element or the molecule that about 20% of the air around you is. 21% is oxygen, O2. And this is a molecule that you are, the reason that you are breathing in and out right now is because that's the molecule you want to go into your lungs and the hemoglobin in your lungs to grab onto and bring the oxygen to your muscles so you can keep living. That's the molecule hemoglobin is grabbing and bringing it back. The other molecule that is in the majority of what's in the air is what? Nitrogen. And that's the one we'll do as our triple bond example. Nitrogen has how many valence electrons? It's in group 15. How many? 5. So I want to show it like this just because we'll make the open electrons closest to the other atoms. And again, if it only shared 2, that would only give each of them 6. And if it only shared 4, that would give each of them 7. But if it shares 6 electrons, by sharing 6 electrons, it gives each of them 8 electrons. And I'm not going to make the big funky thing like I did with the other one because it doesn't help that much. But there's a reason for the triple bond. The reason for the triple bond is if they only share 1 pair, they don't get to 8. If they only share 2 pair, they don't get to 8. But by sharing 3 pair, both nitrogens can get to 8. And here's how you'd show it. And then we have our lone pairs on the outside. And then with dashes, remember each dash represents 2 electrons. So that's why we have 3 dashes here. Each dash is 3 electrons. So single bond, 1 dash. Double bond, 2 dashes. Triple bond, 3 dashes. And then if we're going to go with the actual structural formula, it would just be like this. So tomorrow, so this is just showing you what types of covalent bonds, how they look, and why they must do that. Tomorrow, I'm going to give you something like H2O, like I've already spoken about, H2O, CO2, CO, CO3 with a 2- charge, things like that. And if we have little simple molecules like that, you're going to figure out if there's single bonding, double bonding, or triple bonding occurring within all of those atoms. And it's not too crazy hard. Your book kind of goes over it. With our examples tomorrow that we'll do, I hopefully think it'll be a little bit easier than what the book goes over. You need to look at valence electrons to be able to figure it out, and it works like a charm. All right?